Hello and welcome to the Black Soldier Fly Leaders Podcast. I'm your host, David Tavernor, and in this series we dig beneath the surface to uncover what's really happening inside the Black Soldier Fly industry. Hello to this week's episode of the Black Soldier Fly Leaders Podcast. With me today is Sofia Katzin, who has some great experience in the Black Soldier Fly industry, helping out different companies, whether she's working for them or done some consultation work for them. This conversation here, I hope to be a technical masterclass, or it will be a technical masterclass in black soldier fly rearing, breeding, etc. So stay tuned for some really helpful tips, common pitfalls and things like that in black soldier fly rearing. Sofia, tell me, please, how did you get into the world of black soldier flies?
Awesome. Hi, David. Well, thank you for having me. It's a pleasure and honor, really, to be on your podcast. Since now, as I said, you're a celebrity. Yeah, I feel a little bit, nervous. Yeah, so a little bit about me. I started in the insect industry a little bit by an accident. I am not an entomologist. I do have a big technical background, but it's from the food science and technology, kind of. I migrated, and this is a little bit of a personal journey because everything started with my passion to transform food waste. So I migrated to Australia about 10 years ago, and I started to work in hospitality as any migrant that comes to Australia. And I was seeing firsthand the amount of food waste that was going just to the bin. I guess because there is a little bit of not excess of resources, but more than what we have in where I come from, Argentina, where we think twice before ordering. If you are two people, you just order one pizza to share. Whereas in Australia, I was seeing just three people ordering food for six. And I was particularly working in a very remote area in Australia called Cloncurry. Then we can put it maybe on the show notes, the location. It's 800 kilometers from the coast, so from the next big town. Just to give you an idea, it's like going from London to Zurich, and in the middle, there is only mining and remote towns. So, well, why did I go there? It was really to extend my visa. So it was by choice, but really for a bigger. And in there, obviously, logistics are really difficult. So you can't really ship, or it's not cost efficient, obviously, to track all the recyclables and food waste anywhere else. So everything was either buried in the local landfill, recyclable products, organics, and general waste. And that's where I realized we do have a problem in Australia, which obviously it's a local problem. I mean, food waste, it's an issue all over the world, but in Australia, because logistics are huge, it's a different lens to the problem. And I've started to become a little bit obsessed with sustainability and finding food waste a home, and researching, volunteering, and contacting with people. I reached out to Luke Wheat, the CEO and founder of Arvela, at the time Future Green Solutions. At the time, it was waste management to protein production. Now they pivoted to exclusively breeding. They are on the west coast of Australia in Perth, and that's where I started as a research assistant. So my initial role was substrate innovation, really, and understanding. This was around in 2020, so where there was a little bit of information available, but not so much like these days. And my role was to understand what are the protein, carbohydrates requirements to have, obviously, as everyone wants, the biggest larvae in the fastest time as possible, and as well the biggest flies for more eggs. I worked with them for about 4 years, and 2 years ago, I launched my own consultancy called Fly Mama, where a little bit as Rulon was saying that we see that many companies have the same issues, and they all solve it in a very similar way. I mean, there are different specific solutions. There are some technologies that, yes, could be a little bit IP driven, but in reality, the solutions are not really much of innovation. Sometimes it's just basic, like how much moisture or what's the texture of the feed that you need. So that's why I became a consultant to help other producers to tackle these really simple issues and achieve those high bioconversion numbers that we all want at the lowest cost possible. So it's been, 2 years, and I'm super happy to be part of the industry and just collaborate. I come from South America, so I have a little bit of exposure to that part of the world where resources are different to here in Australia, could be in Africa, South Africa, North America, Europe, and a little bit of Asia. Really, Southeast Asia, I haven't had much exposure, but hopefully in the future.
Well, real breadth of experience across many different countries. So anyone in Southeast Asia, then give Sofia a call. She's desperate for a working trip over there. With regards to breeding, Sofia, in your head, what's the ideal setup? What does it look like? What do you prioritize most?
Excellent. So obviously diet is an important, however, that's not really number one priority. I'd say that climate, it's the most important variable that farmers, producers should control. Obviously, it will depend on which area of the world you're at, but where I am, for example, Perth, the humidity is super low. So we have a minimum of 15 to 20% humidity in summer now. And some days 40 to 42 degrees days. So it's really desert. And in that case, you really need to pump a lot of humidity into the system. So good control, good systems that can manage both humidity, which is also interconnected to temperature.
Yes.
Then
okay.
in let's say,
I found a good example of that was a company in East Africa where they had their main operation around Nairobi in the highlands, where yes, it's humid and yes, it's hot, but it's not as hot and humid as the coast. So they had their breeding operation in the coast where it is hot and humid. And I thought it was a really, really good example of how you can adapt your location to make it work for you and not fix yourself too much on the location, because ultimately the eggs or neonates are easy to transport because they don't weigh too much as long as you've got the conditions in the packaging right.
that's it. Yes, that's it. So as many people say, it's better to transport the larvae to where the waste is rather than the waste to the larvae. So if you have the option to set your breeding facility or breeding operations in a part that it's higher humidity, so this is 70 to 75%, that's like the sweet spot. Otherwise, you're going to spend a lot of money and you're going to have a lot of headaches. And with those days, the rainy days where it pools water, and then you have to manage the humidity and remove that of humidity, or like in here where you have to constantly pump humidity. But, if it's hot, then you need to remove humidity. So then your equipment is fighting the temperature control and the humidity control. So that's really strategy number one. And then I'd say that diet plays a huge factor, not really in the fly stage. However, you can still add sugar water, or some little additives, but it doesn't make a huge difference. What I want to talk about is the diet for the larvae. And you cover a little bit, with Roulon, but so texture, in regards to diet, texture is priority number one. When we talk about texture, obviously it's the physical characteristics. So if it's like too soupy, is it fluid? Is it a rock? Can you pump it through the system? And
what
also
exactly is it about the texture that makes it the right texture, and why is
Perfect.
why does that work for the larvae?
Well, the larvae is what they are, 70%, 65 to 70% humidity inside. And it's a tropical species, so they will thrive in an environment that is similar to them. Otherwise, if it's too different, let's say 50% humidity in the environment or in the diet, they won't be able to crawl. And then if it's too soupy, it's too liquid, then the larvae will drown because they don't know how to swim. So, and how do we measure this? Well, if you have all the budget in the world, you could have a moisture analyzer that gives you results in 2 to 5 minutes, or also viscometer and other equipment, but also could be done with just a microwave. And you could measure, what's the water evaporated in like 2 minutes, with the caveat that the food sample doesn't have to carbonize. Maybe you kind of nodded when I say microwave, so you probably have that experience.
I think what they do in the labs, they probably have some fancy equipment, but when you send off a sample for moisture content analysis, they just put it in an oven, I think, or a microwave, yeah, and it just
Yeah.
evaporates all, and you put it in long enough until all of the water has evaporated. So there's cheap ways of doing it rather than getting fancy lab equipment like you're alluding to, yeah.
Yes, yeah, that's it. Yeah. So even, I mean, if you have no budget at all, you can do just like a squeeze test, like you mix the
Mm.
sample, you squeeze it, it leaks water. That's not good because there is free water pooling. The larvae could go to those corners and then drown. And as well, that won't allow the substrate to heat up really well. When it's too much water, it's called evaporative cooling. So when the substrate starts to heat up, then it evaporates the water rather than being hotter. So then it will take longer for the substrate to increase the temperature, which is not really ideal. I mean, if it
Mm.
takes 2 to 3 more days, it will mean that your bioconversion process, rather than being 6 to 7 days, as we usually say it's ideal, it might take 8, 9 days.
Yes, and it's not the most efficient by heating a substrate through the air if the air is then kind of also taking in the moisture and all of the heat with it.
That's it. That's it. So there is
So
a couple of things. Usually texture, we talk about that. And then, I mean, that's from a biology nutrition perspective, we target many parameters, but none of that makes sense if it's not operationally viable. So if you can pump it through the system, if it's not substrate that will explode in temperature when you put it in the trays and in the chamber. So it's really a compromise between the perfect texture for biology and the perfect texture for operations and engineering.
what about different setups of the breeding chamber, breeding rooms, whatever we want to call them? What are the different variations that you've seen and pros and cons of each one? So, for example, for you can have like sort of small fly cages, or you can have breeding rooms where it's kind of a walk-in fly room, or potentially even a hands-off one.
That's it. Yes. Yeah. Well, you just said it, but essentially you have small breeding cages, could be, like half a meter cube, a meter cube, 2 meter cubes. Then you have a couple that are medium, so 3 to 10 meter cubes. And then you have massive ones, which are more than 10 meter cubes. So it could be 100. And obviously they will be good for different uses. So if you're starting, you have only a couple of cages to manage, you're in a laboratory, you're doing some research, maybe it's better that you have smaller cages because they will be more efficient, they will be more productive. Sorry, my voice is
Take a little sip of water. I'll edit this out. I'll mark it.
got excited. Yes, so there are different setups. You have the small cages that are better for laboratory uses. So let's say half a meter cube, 1 meter cube, up to 2 meter cubes. You will have a lot more production because you have a lot more surface for the couples to mate, to rest, to finish the mating, and then to deposit their eggs. And then if you have a lot of cages, you need to produce, like kilos of eggs daily. Well, then small cages won't really good because you will spend a lot of time maintaining and managing each one of the cages, which are typically small cages, are more labor intensive and less automated. Whereas with big ones, you're more likely to have the attractants, the loading, everything outside of the cage. So it's less time required for servicing. And then
Yeah.
obviously there are different setups with everything inside the cage, like your egg collectors, your pupae trays, which, yes, maybe it produces a lot more eggs, but it's a lot of labor. You need to open the cage, remove the trays, remove the egg collectors. Every time you open the cages, all your flies escape. So that's in a really big commercial setting. Obviously, you don't want those risks. So you might want a little bit less productivity per meter cube, but you have everything outside your cage. And I guess make that efficiently, that's one of the biggest challenges in breeding.
Yeah, I mean, you see videos. Well, I don't know if you're as geeky as me and sees videos online of in China of these like huge sort of, they're almost like warehouses full of flies, and they have loads of things dangling from the ceilings, and all of the egg collectors on the floor, so you can just walk in, collect them up. They might have someone sweeping up all of the dead flies and things like that just to keep it clean. It seems fairly utopian, to be honest, and the idea of a lot of people's nightmares, including my partner's. She would hate that. But to me, that seems like a better setup. But you mentioned the surface area. Is what being, that's important. You've got to have places where the flies can sit, they can rest. You've mentioned climate as well, and then the nutrition of the larvae. What about attractant? What's your experience in making sure that you have the best attractant? Because my own attempts at breeding have been I find it technically really challenging, because the flies they go and lay their eggs wherever they want, apart from where I want them to lay them. They're kind of really naughty children, if you ask me.
Yeah.
So I ask attractant, but how else do you get them to put their eggs where you want them?
Good. You start to speak fly language. I think that's really the best option. So I can we can have it. Yeah. Well, I think as you said, I mean, the attractant, it's key number one, having a good, smelly, fresh attractant. And when we say fresh, it's a little bit contradictory, because you want it rotten. But if you leave it too long, then it starts to be anaerobic fermentation. So when the attractant kind of collapses, and the water either sits on top or sits at the bottom of the solid phase, then that type of smells are not really ideal by the females. And I mean, there is all sorts of opinions out there. Maybe people listening right now and saying like, oh no, we love anaerobic fermentation for the attractants. So, I mean, there is opinions for everyone, but usually, I don't know, like the same food that the larvae have, that those flies had when they were larvae, works quite well. However, if you're paying for your substrate, obviously that will come at a cost, and that's not ideal. The other one that I see a lot of the time, it's dead flies mixed with water, with the pupae shells, with a little bit of frass. And that works really well. You are really recycling your own waste through your own system. However, that sometimes attracts other pests, so it could be ants, other flies, even parasites. Sometimes I've seen them forming. Maybe adding, like again, fresh as you can, or adding a few 5-day-olds or juveniles now and then to move the substrate. And then I've seen also cages, if the pupae loading and attractant it's externally, so those massive cages, usually the pupae are their own attractant. But the key number 2 will be good airflow. Because if you have stagnant air in some pockets of the cage, that will attract the flies to lay eggs. And that's why they go to the corners rather than where you want them to lay. So cleaning also, if you find some of those off-target laying, step number 1, it's clean, not just with a brush, but with some water. And always trying to avoid, detergents or any chemicals, because that could distract the females and males from mating, and then the females from laying eggs.
We don't give them enough. Yes, we don't give them enough credit, do we? We say they're kind of really dirty little maggots, but actually they quite like a clean environment. They're particular.
Oh yes.
Yeah. And it's really hard to get a good airflow, because you don't want to disrupt the air too much for your flies. But then, if you want them to be as productive in the egg laying as possible, then it sounds like you kind of do.
That's it. Yes, that's it. So, like some small fans could be outside of the cage, so the air it's moved throughout the room, not necessarily have to be inside, because you could kind of bother the females as well.
Yeah,
so...
I saw one company doing they had an aerated bottom, so the pupae were at the bottom, and then they had little holes for the flies to fly out of into the cage at the top, which was obviously really light, and the air was drawing up through it, so it was keeping the pupae nice and dry, but also not too smelly, because that was the fresh air coming from there, so the flies weren't laying them near the pupae. But there's all sorts of different things you can do, and some of the technology out there is really expensive, and you'd hope that they've thought all of this kind of stuff through, the technology being the hardware for fly rooms. But then you go to lots, especially the developing world, which is creating fly nets and often doing it outside because it's the environment is conducive to it. But you've got to make sure you still got the right airflow, because when the wind isn't blowing, then you haven't got any airflow. So, like you said, it is really important.
That's it. Yes, yes. I went to Brazil, for example, and some other tropical areas, and in there it's quite low effort, the breathing. You just have constant humidity and good temperature. So you can have those big cages, like I think you were describing, some Chinese malls that we've seen recently, and just they do their thing. So it really depends on different parts of the world. They are more, fussy.
Yes. On the attractant, how do you know when to replace the attractant? Is there any kind of signs?
I'd say like every 3 to 5 days. And kind of developed my own nose to be able to detect these anaerobic fermentation kind of gases, which is like methane. So if you have methane, it's not a good sign. So it's more like aerobic fermentation. So let's say like citrus, sweet flavors rather than, like rubbish waste smell, like from the bin.
Yes, yeah, I see. That's a really important point, having your own nose for it. And it's really undervalued in the industry so far. I think it's catching up. To be able to use your intuition in all of these practices, whether it's breeding or production, that it's so undervalued. And you only get that through experience. It's with the world of data and technology, we value other people's or other known knowledge of how to do things, and we don't use a gut feel or your nose and things like that. You only get that by doing. And so anyone listening to this, you just keep doing what you're doing, and you will build up that knowledge to becoming better at breeding, better at rearing. So moving on to rearing and nutrition, I know you've spoken a bit about why getting the rearing right of larvae is good for breeding, but in terms of a rearing or a grow out operation, someone even called it a fat camp once, which I found quite funny. Could you talk to me a bit about nutrition, because you've got a really good experience in animal nutrition and applied to black soldier fly larvae? So again, open-ended question: what is the ideal diet for larvae, if such a question or answer exists?
Excellent. Yeah. So I guess what I'm going to answer applies pretty much to the diet for breeders and grow out, or the fat camp, fattening, which by the way, they are very funny, all the names that people put to the like lab cage, like breeding, lighthouses, to avoid the cage name. So yeah, it's quite funny. But essentially, as I said before, texture would be number one, or I call it sometimes palatability, because it's not only the texture, but it's also the smell and the taste. So just like, you have this, I guess you are giving solids to your toddler now. So sometimes you can give them the most nutritious food, but if it's like raw spinach and you give a salad, well, they won't really eat it. But if it's a nice puree and it's kind of very easy to eat, they will smash it. And something similar happens to the larvae. So you can give them the best nutrition, but if it's, I don't know, big particle size or too little particle size, and it's a complete smash, then they won't have the pores and the oxygen to crawl through. And then number two, what follows after texture, it's the bioavailability, or what we call and talk about with fiber. Sometimes if you have spent grain from brewery, like, yes, it's really, really good. It has a little bit of protein, a little bit of carbs, fats, but also it has a lot of fiber. So that protein might be locked up in the fiber, and while it's there, the larvae can't really access it. So then that will release a lot of ammonia in the chamber, and that won't be good for anyone, for the workers, because it's, after, I can't remember now the number, but I think like after 10, 20 ppms, it starts to be bad for employees, and then for all the equipment. It's very corrosive. So, if you have any equipment inside the room, everything will start to be like looking red after 6 months. So you don't want too much fiber, but you do want a little bit of fiber because that will feed the microbes inside the gut, just like humans. I mean, we need a little bit of fiber,
I was
but we
going to say
can't just.
we all need fiber. Everything in the
Yeah,
animal kingdom needs a little bit of fiber or a lot of.
that's it. Yes, but like let's say cows and ruminants, they do have different stomachs, so those can resist a little bit more fiber. Where larvae, in that case, they are more like us, or we are more like larvae. I don't know what comes first. And then the third one would be the nutritional value. So what we sometimes, as a larvae nutritionist or consultant, sometimes we speak about like how much protein in the diet. Like is it 20%, 18%, 16? Well, that comes third, right? So first look at texture, then how much it's available, and then let's look at how much protein, which is typically 16 to 18%. However, in some cases, we see 20%, and this is in dry basis. So if you remove the water, 20%, let's say, it's the maximum number that I like to see in protein. Too little, not enough to build like muscle or protein, and then too much will be excreted and then will be ammonia. And again, it's toxic. Then we look at the carbohydrates. That's the energy. They do need about 4 times the amount of carbohydrates to protein. Not enough carbohydrates, well, they won't have energy. And then by day 2, 3, they will start to slow down and they won't be big and juicy. But too much carbohydrates can make them be too fatty at the end when you harvest them. So if you are producing a high protein quality product, then, well, excess of carbohydrates could be detrimental. And obviously fat.
Sorry, carry on.
Yes, obviously fat, it's the other important, and we want it to sit around 6 to 8 to 10% for the case of breeders, and a little bit less, like 6% to 8% for the case of grow out or fattening.
Okay, cool. I guess with the breeders, yeah, you want a bit more fat because then that would last through to the turning into flies as their long-term energy source, right? Okay, so I've written down the numbers here. The ideal, let's call it the Sofia plan, although I'm sure there is a nutritional plan called the Sofia diet already.
Yes. Yeah, I mean, this is, yeah. Let's go with the Fly
So-
Mama recommendation.
Yes, it's 15 to 20% protein. It's 4 times carb, so 60 to 80% carb. Although you don't want too much carb because it will ferment and
it will become fat in the end.
Yes, that's it. And then 6 to 10% fat. So let's say about 6 to 8% fat. What's the rest of it? Is it ash and fiber?
Correct. That's it. Yes, ash and fiber. And ash, you don't want it to be too high, otherwise it will end up in a high ash product. And if you're selling whole fresh larvae, then having high fat and high ash in your product might not be an issue. However, if you're selling high protein product for agriculture or pet food, then yes, ash and fat might be a little bit of an issue in the product.
Yes. What happens if your operation is focused on the fat from larvae, so biodiesel or fat for animals, for animal feed? Is it just simply a case of increasing that fat content in the
A little bit like that, yeah. So obviously more fat in the inputs means more fat in the outputs, and you could have a higher carbohydrate diet to improve the fat in the output. Obviously, if you're selling, I don't know, all oil and fat as a supplement for piggeries, then, well, it really depends what fatty acids you need, because if you're targeting lauric acid, the one with antimicrobial properties, then it's a different type of approach rather than just fat percentage. And the same, are you targeting the omega-6, which are like the good omegas?
So yes,
Yeah.
It's not just a case of launching your maggots into a vat of butter then.
No. It's not that hard, but yeah, you need a little bit of a balanced diet. I mean, like us, right? If you eat burgers and chips, then you might not get too far in life. But if you have a balanced diet with a little bit of everything, then more chances of success.
Yes, I guess it depends on whether us as humans are going to get extruded for our human fat. for biodiesel at some point when we die. I don't know if that's part of the donor list or not.
Yeah.
How about micronutrients? I mean, we're getting into quite a niche level of nutrition science here with black soldier flies. We're only just starting to learn about the macro, which you've just explained. What knowledge of the micronutrients for larvae do you know that are important?
Perfect. So this might not be that, how do you say, important or priority for rearing, because when we start to talk about amino acids, balancing essential amino acids and all the minerals, then your diet starts to be really costly. And usually the aim of bioconversion is to produce the highest amount of larvae in the shortest time possible with the lowest price per ton of feedstock. So this will be more important for the breeding side of things, where we saw that lysine, methionine, which are the essential amino acids, will benefit the fertility of the females, as well as some vitamins. However, at this stage, there is a little bit of contradictory literature. So I've seen papers where it says methionine, it's the only one that matters, and then another one, lysine, it's the only one that matters. So I think it's a little bit of like case by case scenario. And then in minerals, obviously calcium will be better. So a good calcium level, because they will develop like a thicker casing and shell that will benefit once they become flies and emerge.
Okay, yeah, so that's for the breeding operation.
Yeah. And then the last one, and going back to both, so like breeders and rearings, which is like really the priority number 4, would be stability. So how many microbes, how much yeast, how many flora in general you have that may outcompete the larvae. So if it's, like fresh substrate that was just coming from the brewery, and within 24 to 48 hours you're using it, sweet, perfect. Now, if that substrate, it's sitting, 7 days without cover, and it gets a little bit of sun, a little bit of rain, then a lot of bacteria will start to grow. And once the larvae reaches the substrate, then 28 degrees and 70% humidity, it's only really a party for the microbiome, and everything starts to grow, and it might outcompete. So eat the same nutrients that the larvae wants to eat, and you will have higher temperatures. Even like carbohydrates usually facilitates that process as well. So you want to control your substrate before it gets there, or also playing with the temperature of the substrate.
So you're talking about kind of the fermentation that's happening before the larvae getting into it.
Yeah, so uncontrolled fermentation, because then sometimes we see research articles or companies around the world doing a little bit of a fermentation, but it's controlled. It's in a specific environment with specific cultures that are added, usually lactic acid bacteria. So that's control. We know what we are putting in, and we kind of have some sort of predictability on the outcomes. But what I was talking before, what's not good, it's when you don't know how you receive the substrate, and you don't know what will happen once that gets to the chamber.
Yeah, so then it's kind of accelerated by warmer climates, I would imagine, with a very moist substrate and generally grain, cereal-based substrates, so carbohydrates, that sort of stuff is liable to that kind of uncontrolled fermentation. Do you know much about controlled fermentations or feed additives and using those to stabilize or improve the nutrition of feedstocks? Because this industry obviously ideally works with wastes, which can be unstable at times. And so stabilizing them or adding nutrition to them or slightly tweaking their makeup might be beneficial as a pre-treatment before the larvae. Have you had experience working with that?
I had a little bit of exposure to that. So usually when you have high fiber materials, then it's good if you add some bacteria that have the enzymes. So they have the ability to break those fibers into highly digestible sugars. And that will give some energy for the larvae to keep growing, that before the fermentation will not be available because it was fiber and the larvae can't access. So in some cases, it's good. As you said, stabilizes the nutrition profile. So we don't know what's coming. Sometimes we have different vegetables, different fruits, add this bacteria, we have a fermentation, and we kind of have more knowledge or more control over what we are feeding to the larvae. So in that case, I think it's a good strategy. However, if you need to ferment, if it's 24, 48 hours, then you need space to do that, right? Either like a silo or some sort of holding tank. Do you need it at certain temperature? So sometimes it could add some cost to the operations.
Yes, yeah. I mean, I'm from a dairy farming background. Parents are dairy farmers. Could you use like a silage clamp, concrete walls outside and press it, put a sheet on it, and maybe add some different microbes to aid the process?
Yes.
Perfect.
Yes.
I think,
100%.
these are the sort of learnings that we need to take from the agricultural industry for our own industry, for the black soldier flies, using techniques which are pretty low cost. So essentially, you could actually use silage where grass or different kind of fibrous substances that are grown around the world can be fermented and broken down. The fiber can be broken down to be fed in the future to ruminants, but you could also look at it for insects.
That's it. Yes. The only issue with fiber and fermenting fiber is that it releases a lot of water. So then it's kind of a soup and it's very mushy. And then you might the counterproductive effect on the texture. So then if it's too soupy, too watery, too mushy, then you might need to add some low-cost fiber to increase the volume and increase the porosity of the substrate. So you have that good structure where the larvae can crawl inside the substrate.
There's so much to learn. I wanted to ask, so we have a lot of food waste in the feedstock inputs for black soldier fly larvae, and you get all of the variability. We've talked about potentially stabilizing that, but what happens if you've reached the point where you cannot stabilize any further and you still have huge variances and swings in what's coming in for your larvae? What are those kind of thresholds of when it then turns bad for the larvae in terms of those nutrition?
Good question. I guess one strategy if you have like 100%, you don't know what's coming. One day you have more bread, the next one, coffee grounds. The next day you have, prawn shells. Well, that's quite difficult. I mean, you will have, with such variable inputs, you will have variable outputs, and your temperature will spike one day and then it will be quite hard to manage, to be honest. So in that case, maybe I would add, 15% of a product that we know what's in it. So it could be like a dry product, could be like some sort of commodity, depending on where the farm is located, or could be just like another waste stream that, bakery waste or some sort of grain byproduct. So at least we add some sort of homogeneity. I don't know if that word exists. I just made it up. We add a little bit of that to just predict a little bit our process, because it's an industrial process, right? We just can't go to all the neighbors and collect the waste and do it. I mean, obviously it can be done, but it comes at the cost, and probably you need to have like a census made already. So assess first what's coming, have a sample of a few tons during a couple of months, understand what are the substrates coming in, and then it's variable, but I know this is what I will typically get. So you can have a program in your climate control system that can work with that variability. Because there's so many variabilities in insect industry. It's just from everything changing, how can we have some sort of predictability?
Yes, there is a lot of variability. We talk about controlled environment agriculture. You can control it to a point, but external factors like the outside weather, or as you say, the nutrition and the ability for the feedstock to ferment and create its own temperature, all of this stuff is not fully within your control, and that gets ignored a lot, and it needs to be appreciated.
And probably, sorry, with
No, you
what
go.
I've just said, probably applies more if you're focusing on the end product as protein. But if we are talking about waste management, yes, 100%, it can be done with waste. Very variable, but we are not really focused on developing a high quality product. So if it comes with a lot of ash, kind of who cares? It goes back into the fertilizer and then it's sold as a, fertilizer frass, and it can be sold as a soil amendment or fertilizer. But we are not focusing on high ash, high protein, high fat insect meal for all the animal feed industries.
Yeah, it's a really interesting distinction. Essentially, the first thing, the waste processing angle you were talking about, is it's just a different form of composting, probably a better form of composting, to be honest, with the time, the nutrient withholding, and the less greenhouse gases that's produced by the process itself versus composting. And composting it's not about the final output, it's about the processing of the input. If it was about the final output, then there wouldn't be much of a business, because compost is relatively inert and it's just the breakdown of fibrous substances. Black soldier flies does it a lot better and quicker, as I've said. And so it is, again, it's not about the output, but there is more value in the output than there is just from the simple composting process. So it is a really important distinction. I want to move on, Sofia, and all of the guests that I get on generally seem to be from around the world. You're based in Australia and you have been for a number of years now. Can you tell me a bit about what the Australian industry is like and how it's developing?
Compared to the rest of the world or Europe, it's quite small. We don't have that many players. It's usually the same 6 or 7 every year. Some come, some go, but it's usually those. And obviously GoTerra, it's the leading one, it's the biggest one. And then there is many others that either support the operations of GoTerra or do something different. Here, what we have as a, privilege or lack, or however you want to call it, or hard work from the producers, is that we have a little bit of a more flexible regulation. So in Europe, UK, even North America, South America, in many countries, and those exporting to all those countries, they are more strict. And what typically happens is there is a restriction in the inputs where you can only have plant-based and not mixed waste. So can be only byproducts. Here in Australia, we do have a different approach, which is still rigorous. It's just a little bit more flexible. And rather than restricting the inputs, what we do is we analyze, study, and assess the outputs. So it doesn't matter what it was fed on, as long as you can prove that it's safe, it doesn't have pathogens, it doesn't have heavy metals, it doesn't have any nasties, then that is a safe input for your product. And it will also depend state by state. So even though, Australia, it's a country and a nation, we do have different regulations states by states. In the EU, but it's a little bit mixed as well, like between UK and EU. But typically you can feed it to pigs, if I'm not mistaken. Well, here in Australia, it cannot be fed to pigs most of the cases. In all states, it can go to aquaculture and pet food. And in some states, it can go to poultry. So South Australia and Queensland, so where Adelaide and Brisbane are, you can't feed it to poultry. But then obviously, livestock in terms of cattle and ruminants, well, that's a no-no. But as I said, we are still rigorous, but more flexible because we test the outputs, not restrict the inputs.
Yeah, it's a really interesting point of view. Does that put a lot of pressure on the producers to be constantly testing? Well, I suppose it's a lesser of two evils, isn't it? That they are allowed to be fed the input, or that the input has opened up to allow different substrates to reduce the cost. So actually, it's less pressure because they don't have to. They've got a wider pool of substrates to work with.
Yeah, you just said it. Yes, you will have to spend a little bit more money on testing, but obviously you will develop a quality assurance and quality control procedure where not necessarily you will test every single sample, but you do a risk assessment and you understand if you need to test every week, every month, or every 3 to 6 months. But that opens a lot of opportunities, which is accessing waste, which is the real resource that we want to tackle. And as well as some animal byproduct substrates. So I have worked with, in collaboration with another producer that was using slaughterhouse waste. So paunch waste, which is the gut content of the cows and some offals. And that was fed to black soldier flies. And then the BSF meal was used for aquaculture. So that in the rest of the world, it's really like impossible. But for us, it's a difficult waste that has a cost negative, right? Because producers, slaughterhouse houses have to pay to get rid of, and they are willing to pay any cost really because it's obviously not environmentally friendly. So that opens a lot of opportunities for producers here in Australia.
Yeah, it's a helpful regulatory landscape. I just you got to be careful with the testing, haven't you? And there are opportunities wherever you are in the world in different ways, but it is in different ways. It's not in the same ways. In Australia, it seems like you're able to capture a gate fee for the feedstock, but also a price for the output going into aquaculture or what may be. There's definitely opportunities in different countries to take a gate fee for the input, but then not really focus too much on the output and just, like we were saying, it's a royal composting system. It's a better composting system. But then in other countries where there isn't gate fees available because there's no tipping fees to kind of be slightly better than, then it's purely focused on the output. Australia seems like it's got both. So are you seeing more interest in the sector in Australia, or are you seeing more interest from people perhaps looking at Australia, whether it's investors or entrepreneurs, to look into Australia as a place to do it?
100%, and it comes with regulation as well. So a little bit of like the carrot. And again, this depends on state by state in Australia, but let's talk about the more forward-thinking state, which is in this case New South Wales, so where Sydney is based. And by 2026, so this year, 1st of July, businesses have a mandate to separate the organics from the general waste, and they have to reuse it or do something, pay for a company to do something with it. And then by 2030, households as well. And we call it FOGO, so food organics, garden organics. And obviously now business do need to implement a solution, right? It's not just if you want, you can do BSF at your own facility, that there is a mandate. Otherwise, the fines are going to be expensive. And why is this? Well, the landfills are reaching capacity in New South Wales. And like the towns and city are growing drastically. So there is more space. So we need to do something about it. And that's why I think BSF, it's a great opportunity. But having said that, just to give an idea, the landfill levies in New South Wales will increase to $400, which is the equivalent to £200 in the UK. So that's quite substantial.
$250. Yes. That's massive. That is massive.
That's massive. But in Western Australia, the state where I live in, it's only $100. So 50.
Wow, a huge difference.
Yeah, huge difference. And it's because we can put it in the map as well. Perth, it's pretty much the most isolated city in the world. So it's cheaper and faster to fly to Indonesia than to go to Sydney. So we do have a lot of space. There is no competition for landfill. Yeah, there is a lot of unfortunately, a lot of space to dump and hide your waste, which is not the case on the east, which is more populated.
Yes, but still very sparse.
Yes.
That's really interesting. So last episode, which Sofia, you won't have listened to, by the way, because it hasn't been released at the time of this recording, with Chris Smits, who is a waste expert here in the UK. And he talks about the changing regulatory landscape in the UK for for waste, and it's doing exactly what you just said. We're already halfway through the process of all businesses separating food waste or organic waste, sorry, that's in England and Wales. And then next year, or this year, I should say, is all councils have to separate the food waste out as well. So there is a huge changing dynamic here in England and Wales. But what's different to Australia? First of all, you're allowed to feed this stuff to insects. Second of all, and this is really important, is that you don't have as much anaerobic digestion sites infrastructure as here in the UK. And therefore, what option do these businesses have other than landfill? That's where black soldier flies could come in, and that's where it's really important, and it must be exciting. And if you are an investor and an entrepreneur who's willing to go and look at Australia, then it does seem like somewhere that can help, and you can kind of hit the ground running to a certain extent. Or if you are looking to work for a black soldier fly company, then perhaps Australia is the way forward. And I wasn't at the day that Olympia from GoTerra spoke at BSFCon, but she did speak about the changing regulation and how they are constantly having dialogue with the regulators and making sure that it happens, because this could be a tool for Australia to deal with the food waste.
Absolutely.
It sounds like a great opportunity.
I highly recommend to get Olympia on the podcast, because she will have firsthand, because she pushed this regulation as well as all the other Australian producers. So you can get firsthand of what it took to get that regulation happening. And something that I was going to add in terms of anaerobic digestion, well, here in Australia, we don't have that much of a competition with AD. There is biogas for wastewater plants and for methane capture from landfills, but biogas, anaerobic digestion like you guys have, well, no, we don't have that many. I think that, Australia, number one industry that generates the most revenue is mining and oil and gas. We don't have, unfortunately, which you think like, unfortunately, that's AB, it's a little bit of a barrier for BSF. Yeah, like unfortunately, we don't have that many. I mean, now the transition is clear, but at the time, 10, 20 years ago, we didn't have many renewables because we relied on traditional oil and gas sources.
Yeah, that's an interesting point. I was reading up on how Europe and UK developed their AD infrastructure 50 years ago, or started developing it, and it was all about energy security. It was a bit about food waste, but it was all about energy security, and that's, I guess, the difference, and why Australia hasn't developed the AD industry as much, and why Europe has. We've got a huge AD infrastructure now, and actually we're looking at, food waste has only continued to become a higher priority. But food security is becoming a priority now for the nations in Europe and the UK with things like the Ukraine war and growing geopolitical tensions. It seems to be a narrative that's not going away, and perhaps something that black soldier flies could piggyback on as a partial solution to it. Sophia, you've done a great job in explaining the Australian regulations. So thank you very much, and the industry and how it's developing. And I really appreciate you sharing your knowledge on breeding and on nutrition, because it's some really good knowledge out there. If anyone wants to reach out to you, how do they find you?
On LinkedIn. So Sofia Katzin, or also Fly Mama. My email is sophia@flymama.com. Anyone can send me messages or emails. I'm pretty, open to assist. Obviously, I don't give away secrets from other companies, so I respect all the NDAs and all that kind of thing, but it's always helping a friend. They might, reduce a lot of the time that it takes to solve some of the technical issues.
Brilliant. Sophia, I've really enjoyed the chat. Thank you very much for coming on the Black Soldier Fly Leaders pod.
Thank you. Thank you, David.
Now, if this is your first time listening to the pod, then I would really appreciate a like and a follow, and perhaps even a little cheeky 5 stars. It boosts my podcasts up the rankings, and hopefully then advertises the podcast a bit more widely, and it boosts the industry, because that is what we need after a very turbulent 2025. We need to boost the industry, and we need to get the word out there of the power of these little bugs, and shine a light on the industry as to what's actually happening, and give little tips to lots of different people to improving their processes. So please, please, please do that. And I hope you enjoyed this pod, and look forward to the next one. Bye for now.